So hello, my colleagues, and I hope everyone is well. So I want to do some videos here on Chapter 7. So we originally talked about net present value, right? And we kind of said the net present value investment rule is the decision that managers should use to maximize the firm's net maximum value. And in reality, that is what they use, okay? Now, there's a couple other rules that are used, which we're going to go over. And we're going to talk about two of them in particular, the payback rule, okay, which is right here, payback rule, and the most important one, which has got a lot of problems associated with it, which is the internal rate of return rule. So we're going to look at all of these and compare them, and we're going to see how they don't all agree with each other at times, okay? So we'll spend time doing that. First of all, I got to get this to work correctly. All right, so net present value rule, back when we originally talked about that, when making an investment decision, take the alternative with the highest net present value, right? And I think we discussed that already, right? So basically, that's what you want to do. When as far as net present value, that's the rule. So for a standalone project, right, we must choose between accepting or rejecting the project. The net present value rule then says we should compare the project's net present value to 0, which is the net present value of doing nothing, and accept the project if its net present value is positive. Okay, so obviously if we're comparing projects, then you see the one with the highest net present value. If it's all by itself, then basically you just follow this rule here, as long as the net present value is positive and you compare it to 0. Okay. So that's important to know. That's important to know. All right. So the net present value rule is quite simple here. And here's the timeline, right? Again, your initial investment is negative, right? You make your initial investment. Excuse me while I grab a sip of coffee here. And here's your cash flows. And here is the equation. Now, bear in mind, you see the dots here. You got to be careful. This is a perpetuity, right? These cash flows, 35 million starting at the end of the first year. And you see the words here, lasting forever. So the simple equation for a perpetuity is right here. And I showed you how you can use Microsoft Excel to trick it, right? Put about 150 or 200 of the 35s in Microsoft Excel. And then you can get away with that, right? So I believe they do the math here, and the net present value investment rule indicates that by making the investment, the value of the firm will increase by 100 million today, and you could verify that again in Excel. All right, you can verify that in Excel. All right, and I don't know if they give you a discount rate here. So maybe they might have done this, 10%. Here it is, sorry. It's 10%. So you put a 10% there, all right? And that'll give you the net present value will increase by 100 million today. Obviously, 350 positive minus 250 is 100 million. All right, so now we're going to talk about internal rate of return. All right, so the net present value of the project depends on the appropriate cost, and this is important that most people overlook, the appropriate cost of capital. Often there may be some uncertainty regarding the project's cost of capital, and that's the most really important thing. How do you select the cost of capital? So what you do is you basically do a graph of different costs of capital, and you compute a net present value profile, which is a graph here, which I highlighted here. So here's the graph, okay? Here's a graph, and for different discount rates, right? You'll notice that you're going to get different net present values. Now, there should be something that hits you right in the face, that for a certain discount rate, your net present value is going to be 0 right here. You see that? You're not going to have a positive net present value as you would in these cases. So this net present value becomes 0. And that net present value of 0 is what is called the internal rate of return. So the 14% internal rate of return is where the net present value is 0. Okay? So the fertilizer project has an internal rate of return of 14%. All right? In general, the difference between the cost of capital and the internal rate of return is the maximum estimation error in the cost of capital that can exist without altering the original decision. Okay? So here's what you want to do. If the internal rate of return is greater than your cost of capital, you do the project. So this graph shows the net present value as a function of the discount rate. The net present value is positive only for discount rates that are less than 14%, as you can see here, right? Given the cost of capital of 10%, the project has a positive net present value of 100 million. So you can see you'll have positive net present values for anything greater than 14%. Okay? So here's 10%, and so it's 100 million. All right? And now there's an animation tool here for internal rate of return, which you can do. So you should kind of play with that a little bit. Okay, so although the net present value rule is the most accurate and reliable, which it is, right? Most people use the net present value rule. Other people will use a wide variety of tools that are applied often in tandem. And there were surveys done about who used what, who used internal rate of return, and who used net present value, and who used payback decisions. But anyway, so in this survey, 75% of the firms used net present value. This result is substantially different from that found in a similar study in 77 that only 10% used the net present value. So you can see it really jumped over time. All right, so we'll skip this question and answer thing here. All right, so let's look at the internal rate of return here. So one interpretation of the internal rate of return is the average return earned by taking on the investment opportunity. The internal rate of return investment rule is based on this idea. Okay, so this is important. I might have made a video on this already. If the average return on the investment opportunity is greater than the return on other alternatives, okay, you should undertake the investment. So here's the definition. The investment rate of return rule, all right, take any investment opportunity where the internal rate of return exceeds the opportunity cost of capital. Turn down any opportunity whose internal rate of return is less than the opportunity cost of capital. All right. Like the net present value rule, the internal rate of return investment rule is applied to single standalone projects within the firm. Okay. So when we looked at figure 7.1 previously, right? The internal rate of return was 14%. And anything greater than that, you take the net present value. Okay? So that's important to know. And I don't know why I'm stuck here. But hold on. Let me go back for a minute. I guess that's it for this then, right? So, all right. So what we got to talk about is there's a lot of pitfalls with the internal rate of return. And let's just realize that the internal rate of return is not perfect, and we're going to see that in Excel. Okay? So let's go over this first pitfall here. So John Starr, the founder of Supertech, the most successful company in the last 20 years, has just retired as CEO. And basically, they give his timeline, cost timeline, and he's going to basically, right, a major publisher has offered to pay him $100 million up front to, I guess, write his book. Okay. He estimates that it will take him 3 years to write the book. The time that he spends writing will cause him to forego $500,000 a year for 3 years in income. Okay, so you notice the signs are different here. Okay, so the net present value of this investment, which we're going to use Microsoft Excel here, is basically, we're going to use Excel and we're going to set the net present value equal to 0. That's how you get the internal rate of return, right? You set the net present value equal to 0. All right, so that gives you that. All right, so you use the rate. You could use the rate function, right? Because this is if everybody recognize this is a perpetuity, right? I mean annuity, not a perpetuity. I'm sorry, an annuity. And you use the rate function with 3 periods, a payment of 500,000, a present value of $1 million, and it'll give you the internal rate of return. Okay. So this is larger than the 10% opportunity cost of capital. So according to the internal rate of return rule, Starr should sign the deal, but what does the net present value rule say? Okay, so now according to internal rate of return, it says do the project, right? Because this is greater than the 10%. Okay. But now let's look at net present value here, and look at the net present value. This is bizarre, isn't it? The net present value says, no, this is negative, and the net present value comes out negative. So there's a discrepancy here, and basically there's delayed investments here on this problem. So the net present value says, no, don't do that, don't do that. So what's going on here? So we have to look at the graph and see what's going on. So at a 10% discount rate, the net present value is negative, okay, as you can see. So signing the deal would reduce Starr's wealth. He should not sign the book deal. So now we have two things that are not agreeing with each other. So we have to look at a graph to understand why the internal rate of return fails. And let's look at the graph here. Okay, so we're going to plot the cash flows or the net present values here for different discount rates. So here's a lot of different discount rates, and we solved the net present value here for all different discount rates. Okay, you see that instead of putting 10%, we can put all of these. Now, if you graph everything and you look at the internal rate of return, look at this. All the net present values are 0. So you got to graph the net present value to really see what's going on. So to the left of the internal rate of return, it should be obvious to you that you should not take the investment, okay? And you only have positive net present values when you're greater than the internal rate of return. Starr should accept the investments only when the opportunity cost of capital is greater than the internal rate of return. You see what it says here? So basically, that's the problem here. So figure 7.2 illustrates the problem. When using internal rate of return, in this case, for most investment opportunities, expenses normally occur initially and cash is received later. In this case, Starr gets cash up front and incurs the cost of producing the book later. It is as if Starr borrowed money and receiving cash today in exchange for a future liability. And when you borrow money, you prefer as lower rate as possible. Okay, so this is an important consideration. All right. So even though the internal rate of return fails to give the correct answer in this case, the internal rate of return itself still provides useful information in conjunction with the internal rate of return rule. As mentioned earlier, internal rate of return indicates how sensitive the investment decision is to uncertainty. Okay, so you can see what's kind of going on here. All right, so this is an important concept here, that you should always graph the net present value for discount rates to see what's going on. And we're going to look at a couple other pitfalls now too. Okay, so what I'll do is I'll stop this one here, and then we'll look at pitfall 2. All right, so let me just put a little mark there so we know what we're doing. I'll look at pitfall 2 later. Alrighty, everybody.